Okay, guys, I'm gonna get started. Say what? Oh. All right, we're gonna start now. So if you guys want to watch this, I'm just gonna go through the tutorial, and in theory you should be able to do this all yourself. But I'm gonna try and go through it as fast as I can. Not as fast as I can, but just quickly, so that you can get an idea of what it looks like, and it'll look familiar to you when you actually go through it. So if you want to follow along with the lab and/or watch the screen, that'd be a good idea. Okay.
Is everybody on Join.me so they can see what he's presenting? Please make sure you're on.
Did you give them the Join.me number?
Just because, like I said before, HyperMesh is a lot less intuitive than Catia is. So if you're already struggling with Catia, HyperMesh is going to be a lot harder than that. So
all right,
please pay attention to this, because this is a good chunk of your project, and
hello.
they'll be able to give you guys a lot of good pointers and helps to take really.
I'm on the phone with Alex, but I can't hear him right now. I don't know if he can hear me or not. Oh, he said he can't hear me.
Oh.
I'm going to call Andy, and then I'm going to include Alex in the call. Are there any others besides those two? Okay. Hello. Hello. Okay, I heard something at the beginning, but now I can't hear you. I'm going to add Alex to the call. And so, if you guys just want to listen on, can you hear me? You can just send me a chat message, I guess, if you can hear me. Oh, okay, great. All right, I'm just going to get started then. So, all right, so when you open up HyperWorks or HyperMesh, remember it's Start, at least here at BYU, Start Programs, CAD Programs, Altair HyperWorks 10, and then HyperMesh is what I opened here. And when it pops up, this window should come up, User Profiles. So in this case, since we're going to be running OptiStruct and doing an optimization, we want to make sure OptiStruct is checked.
So OptiStruct is what is used to do topology and all that sort of stuff?
Yes, yes. HyperMesh is the mesher and the preprocessor. OptiStruct is the name of the solver that runs the optimization. So if I click OK, you can get back to that by going to Preferences, User Profiles. Will bring up that same menu if you need to. So I'm going to open the file. Make sure you download this file from the website, the CARM or CARM. Here we are. And so here is our part that we will be working with. So, so it says that we should create materials. As you can see from previous labs and from previous tutorials, we have these different components. We have RBE2s, which are the little gray connectors here. As you can see, they pop up like this. And then non-design space is this yellow part. And then the design space is the light blue part. So those, in this optimization we're going to run, the yellow is going to stay there. That's not going to be, it's not going to take away any of that material. But it will, OptiStruct will know to take away this light blue material. And so we're going to set that up so that happens.
What's the gray again? What did you say the gray was?
Gray are RBE2s, which are rigids. They're one-dimensional, just lines that are elements as well. But this lab doesn't talk a whole lot about them. So first we need to create materials. So you right-click here and you say Create Material. And it says, let's name it Steel. And we'll keep it red or so. And then it says, make sure the card image is Mat 1. And it says if you create edit, it'll bring up this, it was called the card edit menu. If you don't do that, you can always just right click on Steel and say card edit, and it'll bring up that same menu. So now if you just click on E, then
Right click on it, it doesn't stay.
oh wait,
What units is E?
I don't, I'm sorry, I don't. Good you. So right, so we click on E and it'll bring up this menu. If you want to get rid of it, you can just click on it again.
Wait, how did you bring up the preference? I'm sorry.
This window right here,
Yes.
if you just right click Yeah, if you right click and say card edit. If you click edit
I don't have material on this product.
over here, did you create a new material?
Okay.
So create material. So once we're in the card edit, and we're going to make it 2e to the 5th, and then also new, it has us enter 0.3.
What's new stand for?
I don't recall.
Oh, is that proportion ratio?
Yes, yes. So now we create that material. Yes.
If I click card edit, it like flashes that screen that you have, and then it goes back to the regular edit screen.
Make sure your mouse.
I don't know. And to be honest, guys, I would prefer if you want to follow along, go ahead and try, but I don't want to drag this out too long.
Alright.
I think it'd be bad. I'm just going to go, and then I would suggest just watching, and then because you should be able to do most of the tutorial by yourself. And I'll try to finish this quick, and then we'll just walk around and help you on anything else. All right. So steel. Now we're going to create a new property. So we right-click and say Create Property, and this one we're going to call Non-Design Prop. And the card image on that, we want it to be a P solid. There you are, P solid. And the material, we're going to make that steel, the material that we just created. And then we do another one called, so here's our non-design prop. We're going to make another property called design prop. And same thing, make this P solid. There you go. And steel. So now we have these two properties. Now we want to assign these properties to the different components. So if we go, it says to go to collectors, assign component property, and we're going to assign, and then the comps, we want to assign non-design, the non-design component. As you can see, it selected that component out here. Click select, don't click return. If you click return, it won't select it. So you click select, now those are selected, and the property that we want, if you click in here, we're going to assign that to non-design property. We click assign, and that assignment has been made. So we'll do the same thing for the design property. Design, select. Now you can see the design component has been selected, and the property we want is design prop. Assign. So now those assignments have been made. There's been a connection in between those two. And then we click return. Now we need to create some load collectors, and then we will make loads inside of those load collectors. So if we right-click and say create load collector, and the first one it wants us to make is called SPC. Now SPCs are rigids. They're the constraints. So I'm going to make this one white. And on card image it says make sure it's set to none. And we say create. And now we have a new load collector which is white, and it's called SPC. Now we're going to make a couple other ones. One is going to be called break. Now I'm going to make that one red. And create load collector corner. And one more called pothole. Create. Okay, so now we have these 4 load collectors, and now we're going to make constraints. We want the constraints to be created inside of this collector, the load collector SPC. So we want to make the SPC current. Right-click, make current. So now when we make a constraint, it will place it in this load collector. So we will make a
SPC stand for?
I don't know what SPC stands for.
Single point in screen.
Right. Thank you. All right. So now we go to analysis. Now that SPC is current, we know that it'll be created in that collector. So we go to analysis, and we go to constraints. And so it says create a constraint at a node. And so what we're going to do is it wants us to zoom in and create it at this node right here. So as you can see, there are all these nodes on these different elements, and they all have these are called rigids connected to this one node. So if we create an SPC, so as you can see, I clicked on it, and there's a little white ball that's been created there. It's kind of hard to see because of all the lines. Now that is selected, it will create a constraint at that point. So we want it to be, we want to constrain the first 3 degrees of freedom, but not 4, 5, and 6. So the degree of freedom 1 is translation in the X, translation in the Y, translation in the Z, and 4, 5, and 6 are rotation. Rotation in the x, rotation in the y, rotation in the z. So by creating a constraint here, and I think that's good, so we click create, it makes this triangle, as you can see, and even if we rotate things, the triangle will stay like that. So we know that this point is constrained, and you can even see, I don't know if you can see that, but there's a 1, 2, 3 right there, which means that this point has been constrained in the first 3 degrees of freedom. So it cannot translate in any of the degrees, but it can rotate. And so we're going to make another one at this node, right there. So I just clicked on that. But we want that one to just be just 2 and 3. So if you can see what's going on here, the x direction, which is this way, this side will be able to slide, it'll be able to move in the x direction, and it'll be able to rotate in any of the 3 directions, but it can't move in the y and the z. And so I'm going to click create, and now we have that second one. And so this setup makes a pretty good simulation of what a pin would act like, right? All right, so now we want to create another node that'll simulate a shock absorber, which is attached right here. You see where they have this little RBE thing right there? So if we click on nodes, and we want to select a node by ID, and it tells us to do 3239. Click enter. Now you can see it selected that node, because that's the number, that's the ID of that node. And it says we only want to constrain the 3rd degree of freedom. So I click create, and now there is, if I view it this way, you can see there is another constraint there, and you can see it's only the degree of freedom 3 that has been constrained there. See that? So this thing will not be able to go up and down. It can move any of the x and y, but it will not move up or down. Okay, so now we have those constraints done. I'm going to click return, and they're all in the SPC collector. You can see if I turn this SPC collector off, they disappear, and I can turn them back on. So now we're going to create loads. We're going to make forces. So back in analysis, or sorry, over here, we want to make the brake current. So we say make current. So now when we make a force, it will place it in the brake load collector. And we go to analysis, and we go to loads, or forces. Yeah, forces right here. And so we want to create a force, and at which node we're going to select a node by ID, and it says that the node is 2699. And click enter, and as you can see, it just selected this node right here. See how this one's white? Which is the end of these RBE2s that they have made there. So now on magnitude, it says we want to make this force 1,000, whatever the unit is right now, and we want it to point in. You can this will be able to tell you which way you want to point. You can say point along a certain vector or these 3 nodes. In this case, we're just going to make a force in the x direction. And all right, so let's click create, and it created a force at that node pointing in the x direction. And if you wanted to point in the opposite direction, you would just put a negative 1,000, and it would point in the opposite direction. Now it also says, since this is really small, we can make it look bigger by clicking uniform size, and we're going to make this 100. And now it's going to be easier to see. That doesn't change how big the force is, that only changes how big it looks on our screen for visualization. Okay, so now we've made that one in the brake. You can see I can turn it off and on. Now let's make another one in corner. So we right-click on corner and make that one current. And then now we're still in this panel, so if we make one, if we click create, it'll put it in the corner. So let's select that same node again by ID 2699. As you see, it's selected again. We want another one, a magnitude of 1,000, but we want this one to go along the y-axis. And we click create, and there's the second force going along the y-axis. So we'll do the same for pothole and the z. So we make this one current, and we'll, in fact, I'm just going to click on this node. We know it's going to be there. So I have that node, and then this one's going to be in the z-axis. And click create, and there's that third force. So now we have those 3 forces, and they're each in a different load collector, as you can see. That one's in brake, that one's in corner, and that one is in pothole. All right. So now we need to make load steps. So we hit return, and we're in the analysis again, and we go to the load steps panel, which is right here. So